So we saw previously that given a principal P and interest R, then if S is the value after a single compounding period, we can write S is equal to P times 1 plus R. Great. The problem was that in order to be able to determine the value after 2 or 3 or 4 compounding periods, we had to know what it was after 1 compounding period, 2 compounding periods, 3 compounding periods, and so on. So our goal this time is to compute Sn, and we're going to let Sn be the value after n compounding periods, and we'd like to be able to do that without having to compute all of the intermediate steps, S1, S2, S3, and so on. And the way that we're going to do this is we are going to go through those steps and compute those intermediate compounding periods, but we're going to hope that the value that we get at the end of the day only depends on P, R, and probably N, so that we don't have to compute all of the intermediate steps. Okay, so the value after the first day, S1 is P times 1 plus R. We already know that. Now when we want to compute S2, so the compounding interest after the second day, we're going to use S1 as the new principal. So let's plug that in using S1 in the equation as the principal. And if we write out what S1 is, we get P times 1 plus R times 1 plus R, and we can gather to get that together to get P times 1 plus R squared. Great. So let's look at this and see hopefully the beginning of a pattern happening. We're going to repeat this. So now for the third compounding period, we're going to use S2 as our new principal. So we can plug that in. And we'll use our previous value for S2 into here and multiply that by 1 plus R. So we get P times 1 plus R cubed. So notice here the pattern between the number of compounding periods that have passed and the exponent of the 1 plus R term. They seem to be the same, right? So in the third compounding period, the exponent of 1 plus R is 3 as well. So what that seems to tell us is that every single compounding period that we pass through, we end up picking up a factor of 1 plus R. So this is going to allow us to figure out what Sn is. Well, we've passed through n compounding periods, so it should be P times 1 plus R to the power of n. And there it is. There's our formula. We now don't have to compute any of the intermediate steps. We can just go directly to this value. Let's start off with a simple example to begin with. So let's say that you invest $1,000 and you're earning 2% every single day, right? And of course, this is, again, an absurd example. If someone offers you this, you should absolutely take it. But let's figure out what the value is after a single year. So our principal is easy. It's $1,000. The interest rate is 2%. Now, what is n? At this point, you should actually pause the video and see if you can figure out what the value of n is. And if you've done that, hopefully you got 365. So we're compounding daily, and we've gone over 1 year. So there are 365 days in the year. That's 365 compounding periods. If we plug all of this into our formula, okay, we're going to have to use a calculator to figure this out, but we get something a little over $1.3 million, which is, of course, just a crazy amount of money, right? We started with $1,000 and we ended up with 1.3 million. Now, if this had been just simple interest, so not even compounding, we still would have earned a lot of money, right? We would have earned about $20 daily, 2% on 1,000, but at 365 days, this only ends up being a little over $7,000, which means we would have had about $8,000 total, not $1.37 million. So this should give you an idea, again, of the power of compounding interest. All right, let's do a slightly more complicated example this time. So let's begin by supposing we invest $100, and let's say we do it at 1% monthly. That's a little bit more realistic than our previous example. So we do it 1% monthly and we do it for a year. Now, at the end of that year, we take another $100 and we throw it onto whatever the value of our account is. We're going to invest it for another 2 years, but this time at only 0.5% monthly. So let's figure out what the value of this account is after the full 3 years. Okay, so let's start by figuring out what the value of the account is after a single year. And we know what the principal is, right? That's $100. The interest rate is 0.01 because that's 1%. N is 12, right? And it's 12 because we're compounding monthly and there are 12 months in a year. So that means there are 12 compounding periods have passed. And if we plug everything into our formula, again, we're going to have to use a calculator, but it's not too bad. And we get 112.68. Okay, so now we're going to throw, right? At this point, we're supposed to add in another $100. So that's going to bring our new total to 212.68. And we're going to repeat the computation using this as our new principal. So we're kind of resetting the day. We're pretending that it's, day 0 again. And we're going to use this new principal of 212.68 compounding monthly for 2 years at a 0.5% interest. Okay, so again, R is 0.05 because 0.5% interest. N is 24 this time, right? Because we're compounding monthly, but for 2 years. So that's 24 months, 24 compounding periods. And so after another 2 years, we're just going to plug everything into our formula. And we're going to have to, again, use a calculator to work this one out. We're going to get 239.72. Now, me personally, I love to kind of keep things exact. So instead of, computing 112.68, 239.72, let's redo the computation, but let's kind of keep everything together. So the principal at the beginning of year 1 was S12 plus 100, right? It's what we'd earned after the 12 months, and we added on $100 to that, and then we compounded that at 0.5% for 24 years. So here, all I'm doing is just expanding out the numbers that we'd already computed, but not evaluating any of them. And this is a totally fine answer as well. And in fact, there's a very real sense in which this is a very nice answer. It obviously looks bigger and more complicated, but we know it's exact, right? We don't have to worry about any rounding.